Hello everyone, and welcome to another year and a whole new video curriculum setup. Okay. Before I really begin, I do want to talk just ever so briefly about the history and why I have to shoot a new video setup here, or another video curriculum. If we look, I'm going to show you what we used to use. This is the Teensy. I love this chip. I still love this chip. It's a great chip. It's got an ARM architecture, a 3.3 volt core. It's got lots of power, lots of speed, lots of capabilities. It's a fantastic chip. And we had it coupled to a board like this, okay, which allowed really easy access to all the pins. We had special sockets here for expanding things like Bluetooth and Wi-Fi and various other things on it. It's a great setup. So why switch? Well, turns out that we've been having increasing difficulty with this chip and reliable communication with the student Macintoshes, and became kind of a hassle. And so we've decided, all right, I guess we're going to have to switch to a slightly different processor. So this year will be the first year that we're moving to a system like this. Okay, and these are just a small sampling of the different types. These are Arduino Nanos and Nano compatibles. And I have 5 of them right here, and they're all different, but what they do share all the same is that they all have the exact number of pins, and perhaps way more importantly, the pins all have the same basic function. So a power pin is always going to be in the same place. A ground pin is always going to be in the same place. So I can simply, if I want to change the functionality of something, I can simply swap out the chip, okay, and increase the functionality. So, for example, this one right here does not have Bluetooth. It does not have Wi-Fi. So, rather than plugging in an external board, we'll simply swap it out with a chip that does have Bluetooth and does have Wi-Fi. And now we've added that additional functionality to it. So, there's upsides and downsides to it. One of the downsides is we got a lot more choices we have to make when we choose whatever chip we're going to use. But the upside is that we do have more diversity, more choices, even down to the programming language that we choose to use to work with these chips. But before I jump into all that, let's just take a quick look at some of these other options of the Nano chips. And if I go here, you can see that there are a number of different Nanos. Each and every one of these things has a different chipset, a different capacity, different abilities, different potentials in programming languages, any one of a number of differences that make them all unique. We're going to start with this Nano Every right here. It's a perfectly great chip. It's not super fast, but that's okay for what we're going to start with. What is nice about it, it is 5 volts, which for our purposes is going to make it more robust when we use some of our older legacy products and boards that break out. Of course, it's a more affordable chip. But we will also be using this year, I have, now I'm losing sight of it, the ESP32, there it is, okay? So the ESP32 has much more capacity, it's a little more expensive, but it does have Bluetooth, and it does have Wi-Fi, and it does have a 3-color LED. All these things are built on board, okay? But we don't have to stop there. We can choose any one of these chips. This one has a bunch of sensors on board, okay? So if you want something that's a freestanding unit that's able to sense a number of different environmental factors, well, this is the chip for you. If you want to be programming in MicroPython, well, maybe this is the chip for you. You have to choose the chip that's going to fit your project. But like I said, for our class this year, I've chosen 2. We're starting with the every, and we're going to migrate over to the ESP32 once I feel confident that you can work with it without burning out my chips. So, that being said, let's bump back over here. So we got all these different chips. We're going to start with the every. Alright, so I get this one out of here. And I should take a look and explain some of these pins and then how we're going to take advantage of those pins and what we're going to use them with. So, let's take a look here at the pinout. So if we look at the pinout of the Nano Every, it's relatively simple in the world of embedded controllers. You can see that I have some things that we're not going to mess with. We certainly don't want to be messing around with VN and ground. Those are all built into the board I'm about to show you. But what we will be using is many of these I/O pins, these input-output pins. And if you see, if we orient ourselves to the USB socket here, on the right side, these are all going to be digital-only pins. Okay. RX and TX, they are actually D1 and D0. They have special purpose built in for transmission and receiving of serial data, but we can use it for other purposes. And the rest of these go up in line from D2 to D12. And again, these pins are predominantly digital pins. In other words, they can see a high, a low, a 1, a 0, a true, a false. Okay, false. Those are going to be the primary ins and outs of these pins. On the other side, you can see that some of these pins have an A. This one's a D13, so it's a carryover from here. This A means it's an analog pin. Okay. Now this pin is both analog and digital. In fact, all of these are both analog and digital, which means I can use this pin absolutely perfectly fine to determine a 1 or a 0 or a true or a false. Okay, no problem. But I can actually tell the processor to look a little beyond that and say, I really want to know how much of a value it is. So instead of just reading, light and dark, I can see how much light it is. Or hot and cold, I can see what the temperature actually is. So these pins are able to measure the spaces in between, whereas if I use them as digital, it's just 1 and 0. Again, all these pins have additional functions. We'll be talking about those as we move into them. But right now, for the first couple of weeks, I'm pretty much interested in the digital aspects, the 1 and the 0, and the analog aspects of it. So if we come back over here, how are we going to be able to access it? Okay, we will be using a board like this. And you can see it has a lot of legacy characteristics of the board from previous years. The sort of standard overview is it's color-coded as much as practical to make it easier to understand. All of these yellows, all these yellow pins here, and all these yellow pins here are directly linked to those pins on the processor. So this is D0, D1, D2, D3, D4, D5, all the way up to D12. It's hard to see, but you can with your with your younger eyes, be able to see that the number is in fact written in here, so you can look across. If it's difficult to see, just count, starting at 12 working back or 0 working up, and you'll be able to find, for example, where D6 is. This is going to be the analog side, okay? And let's not forget, let me show you again, that very first one up there is D13. So if we come back over here, and it's a little difficult to see, but don't be tricked. That is not a 0 at the very top. That is D13. Okay? Then it goes 0, 1, 2, 3, 4, 5, 6, 7. Okay? So these from the second pin on down, and it is actually labeled in there. Boy, it's hard to see, but it's in there. Those are going to be your analog pins that you can use. Now, let's talk about the red pins. So the red pins and the blue pins in your case are going to be power pins. They're going to output the voltage that I need to run whatever circuit that I'm going to run. So for example, if I have a small servo motor like this, I can simply plug it in, making sure that my lightest color is on the lightest color and my darkest color is on the darkest color. And now I have direct link to the I/O, to the power, and I haven't explained it yet, but all the black pins here are ground. So each and every one of these pins, all of these, and all of these are connected below the board into one solid bus. So it doesn't matter which pin you choose, okay? They're all going to be interconnected and they all go to common ground. Now, what's different about these blues? All right. These blues are fixed at 5 volts. All right. You cannot change the voltage of these inner pins here. They're going to be 5 no matter how hard you try. They're going to be 5 volts. These pins, I can choose the voltage. I can say, okay, I want it to be 5 volts, or I want it to be VN, which means it's whatever is plugged into the battery port here. Okay, so if I have a battery pack with 6 AA's in it that are rechargeable, that'll be, well, each battery is 1.2 volts, so that'll be 7.2 volts that I put into this. So with the jumper set on VN, if I actually move this and put it here, now all these red pins are going to be 7.2 volts. If I put it here, they're all going to be 5 volts. Likewise on this side, okay, if I want these to be 5 volts, I set the jumper where it is right now. If I move this jumper over, which I won't do right now, that would switch this to 3.3 volts. Okay? So I can change the voltage that comes out of these red ones by choosing which jumper goes here. Last but far from least, these 2 switches. You might notice that the switch is kind of awkwardly placed. If this is like this, then I cannot plug my port in. Okay, it'll block it. So it's going to require you to flip the switch this direction to turn on, to be able to plug it in. This switch turns on and off the system. It turns on and off power to the chip. So when it's plugged into your computer, I'm assuming you want the power on and it's powered directly from your computer. When it's and you won't be able to flip the switch. All right. The reason is that if I'm running batteries at 7.2 volts, I don't think I want you to be able to feed 7.2 volts into the circuit and make it possibly backfeed into your computer. So the switch has to be here. If you're plugged in, if you're unplugged and you have batteries, this will be the switch that you use to turn on and off the system. But it'll only turn here if it's not plugged into your computer, and that would turn it on if it's on batteries. This switch, simpler in function, its sole goal in life is to turn on and off these red power right here. Reason is, if you have a motor on it and you're programming it, I don't want you to have your robot drive off the table as soon as you hit upload. All right, you can turn your motors off, okay, and keep it any way you want, but that way you can upload, you can program, you can test, and you do not have to worry about your robot driving off. But you do have to remember to turn it on if you want your robot to move. So, that being said, I think I'm going to end this video, and I will see you again really shortly as we continue on with this curriculum. Talk to you soon.